So now I want to discuss likelihood function. What is likelihood function? What is likelihood function? So likelihood function is the joint probability mass function or joint probability density function. Okay, joint. So I said here joint probability mass function. Mass function, probability mass function for the discrete data. You know about this, right? And joint probability density function is for the continuous data or quantitative data. Okay. Example. Example. Suppose x1, x2, x3, xn are IID. IID. IID means what? Can anyone tell you what is IID? Suppose x1, x2, xn are IID, independently and identically distributed. From a binomial distribution with success probability P, then likelihood function of x1, x2, xn can be written as, then likelihood function of x1, x2, xn can be written as theta given x, or it is sometimes written as theta because x1 is given. It is written as probability of x equal to x1 times probability of x equal to x2 times probability of x equal to suppose xn. This is the multiplication, okay? For Poisson distribution, I will give you explanation, details explanation. For Poisson distribution, the likelihood function theta given x, I write here x like this way. This means this x means actually x1, x2, xn, all of this. Okay. So for the Poisson distribution, it should be theta probability of x equal to x1 times probability of x equal to x2, probability of x equal to xn. Okay. So let me write here, suppose theta equal to lambda. Okay. Suppose theta equal to lambda. So now see how I am writing these things. I am writing these things e to the power minus lambda, lambda to the power x1 divided by factorial x1, e to the power minus lambda, lambda to the power x2 divided by factorial x2, e to the power minus lambda, lambda to the power xn divided by factorial xn. Okay. Joint probability, what did I say? IID means independently and identically distributed. Because of independent, there is a multiplication. Okay. Understand? Okay. Now let me tell you. Let me write you some other place. Let me write it in the next page. Okay. A and B are independent. What is the meaning of this? So mathematically, joint distribution of A and B equal to B. This is the definition. Okay. So this is the independent. So because of that independent assumptions, because of that independently, okay, I multiplied this. Are you seeing multiplication? And identically means what? Each distribution from x1 is coming, which has a rate lambda, x2 is coming, which also has a rate lambda. Xn is coming from a distribution which also has a rate lambda. On the other hand, if your distributions look like this, e to the power minus lambda 1 over x1 divided by factorial x1, e to the power minus lambda 2 to the power x2 divided by x2 factorial, e to the power minus lambda n to the power xn divided by factorial xn. Then in this case, it is independently but not identically. Understand? This is independently distribution. This is called the x1, x2, xn are independently distributed. Which follow Poisson distributions with parameter lambda 1, lambda 2, lambda n. Understand, right? So now you clear what is independently IID. Okay. Now let me come in here. Let me erase these things. I don't know. I don't need this. This is called independently distributed ID. Come from here to there. I can write here e to the power minus m lambda and lambda to the power sum of xi divided by I goes 1 to n factorial. Can I write like this way? So how many lambda? This plus that. There is n lambda, right? So that is why it has been written n lambda. So don't now I'm coming from here to there. So these can be written e to the power minus n lambda, right? Are you understanding? Gentlemen, are you okay? So I am adding this and that. So e to the power minus m lambda and lambda to the power sum of xi divided by xi factorial like this. Clear, right? Everyone okay? This is called the likelihood function. So likelihood function, now what I had? L of lambda equal to this. Now I want to take log of L lambda, which is known as the small l lambda, is n lambda plus sum of xi log of lambda minus phi I take log on both sides. This is the log. Sorry, I missed the log in there. Let me rewrite these things so that things will be clear. Okay. Log. Clear? Okay. So now if you differentiate this, yes.
The last sign equates that for I is equal to 1 to n.
Yeah.
The sign
Here.
next line.
Here.
The last one. Log
Yeah. This is log phi. Phi. This is called the multiplication sign. This is called the addition sign. This is called the addition sign. This is called the multiplication sign. So if you differentiate this with respect to lambda, you are getting there n, you are getting there sum of xi over lambda, you are getting there 0 because there is no lambda is in here, right? You are differentiating with respect to lambda, right? And then you have a 0. Clear? So now first order derivative 0. So that means maximum likelihood function means that function for which the function will be maximum. That is why. So we are finding the value. So now if you solve this, you are getting minus n equal to minus sum of xi over lambda. And then from there, if you want to estimate sum of xi over n, which is equal to x bar.
I will be at 1 lambda.
This is now I'm estimating. If you estimate it from the, because this is x1, x2, x3 is given. So from there, I am getting this. This is the estimate. So if you collect a sample and if your friend collect another sample, those sample will be different, right? So your estimate will be different from your friend's estimate. Clear, right? You are understanding, right? So now by using likelihood function, we have estimated the parameter of the Poisson distributions. Poisson distribution has a mathematical format like this: e to the power minus lambda, lambda to the power x over factorial x. And in this is the distributions that take shape like this: x takes value 0 to infinity, lambda is greater equal to 0. But lambda value, how can I? Lambda is a parameter, lambda equal to parameter, right? Which is taking value greater equal to 0. So it has another name, unknown constant. Unknown constant. So this unknown constant can be estimated by maximum likelihood method, which is this. The estimate is this. If the online student Shafali, she collects a data, I collect another data, and my friend Bhaskar collect another data. you collect another data. All of our estimate value will be different, right? Because sample is different. So what is parameter? Parameter means unknown constant. All probability distributions has parameter. Normal distribution has two parameter. Binomial distribution has two parameter, n and p. Poisson distribution has only one parameter, lambda. Okay. Exponential distribution has one parameter. Weibull distribution has two parameter. Parameters is the unknown constant which needs to be estimated from the sample data. What is the approach? Maximum likelihood approach. There are other approach of estimation, Bayesian approach and other approach. Okay. So what you have learned, anything like probability distributions, the parameter could be estimated. So Poisson distribution parameter lambda mathematically estimated, which is equal to this, and I have shown you. This is the distributions of, this is the estimate of the Poisson distribution parameter. Okay. Now I want to convince you another. I want to also find the variance. Okay. I also want to find the variance. In order to find the variance of variable x, you know, this is the formula for the variance, right? This is the formula for the variance, right? Everyone know this. So now find this formula, this variance. In order to find this variance, that could be written as probability of x equal to x. And what is this value? Expected value of x of Poisson distribution equal to what? We just found it, right? Lambda. So this is lambda square, right? Good. So you are following me. That really makes me happy. So that is equal to x into x minus 1 plus x. That could be written like that way. And then here to the power minus lambda, lambda to the power x over factorial x minus lambda square. X square can be written x times x minus 1 plus x, right? This x square has been written in this format. And rest of the thing I did not change. Are you okay, Mahabub?
Yeah.
So now take a look at that. X takes value here 0 to infinity. So I want to now multiply x minus 1 e to the power minus lambda, lambda to the power x over factorial x. And then I want to do these things, x equal to 0 to infinity, x e to the power minus lambda, lambda to the power x over factorial x minus lambda square. Can any one of you tell me what is this? Last portion. This is just the lambda, right? This is just the mean, right? X times that. Okay. So now what we have in here, x takes value here 2 to infinity, because 2 will be gone in here, x into x minus 1 e to the power minus lambda, lambda square, lambda to the power x minus 2, and then here I can write here x minus 1, and then x minus 2 factorial. This x factorial can be written like that way. X factorial can be written like that way, right? This lambda to the power x can be written like that way. Okay, so now this and that cancelled out. This is equal to lambda square. Tell me. It is always infinity. Why did I write 2 to infinity? Who can explain? Previously it starts from 0, right? But now I cancelled out how many x's? Here I cancelled out Because it starts from 0. Now we cancelled out 2x's, so it will start from 2 now. Not sure? His question is why it is from 2, right? Oh, the previous one already gone. So it is in it is in there. Okay, it is in there. It is in there. Take a look. It starts from 0, right? Then it switched to 1. Why?
Because you separated them from.
Yeah, this one and that one, 1x cancelled out, right? So now x goes 1. Similarly, that one, 2x cancelled out. How many x's cancelled out in here? 1 and 2, right? So now if you write like this way, e to the power minus lambda, x goes 2 to infinity, and then lambda to the power x minus 2 and x minus 2. Then you have lambda minus lambda square. Yes.
In the last line, third line, upper third, we cancel out just one x from there, but we got x equal to 2.
No. Here is 1. Here is another 1. 1 and another 1. 1 and another 1. Got it?
Instead of saying that we submit 0 or 1 there, we'll get 0 and so
If you still put here x equal to 0, then there will be 0 minus 2. 0 minus 2 equal to negative.
0, we had x there, right? Before it. If you substitute 0 or 1 with the value, we'll get 0, so we can ignore.
Or in this case,
Yeah. So substitute 0, we get 0. Substitute 1, we get 0. So we can start from 2.
okay, I understand what are you talking. So this gentleman is saying it starts from x equal to 0 to infinity. He wants to put 0. Then if you put here 1, what will happen?
The third step I'm saying, where you change it to
Here, if you put here 1, then it will be 0. You have to make like this format so that it will never go down any quantity that is exploding or making everything 0. This is a simple thing. So x times x minus 1 and x times x minus 1. 2 x's is cancelled out, so that is why. Now, if you plug it in there, e to the power minus lambda, what are you getting here? 1 plus lambda over factorial 1, lambda over lambda square over factorial 2, lambda cube over factorial 3. It will go all the way like this, plus lambda minus lambda square. Okay? We have a lambda in there, right? We have a lambda square there. We have a lambda square there. This lambda square. Right? Are you understanding? So now we have lambda square, e to the power minus lambda, and then e to the power plus lambda minus lambda square. So these two cancelled out. So e to the power lambda square plus lambda minus lambda square. These that cancel, we have lambda, which is equal to variance, right? We are finding variance, right? And also mean. Poisson distribution is the only distribution that has the mean and variance same. Understand? Poisson distribution is the only distributions that has the mean and variance is the same. Now, in your conceptual part of the exam, if I say like we want to predict the number of birds that come to visit a specific tree in our backyard based on the ages of the tree and the types of the fruits, and also maybe time of the month or time of the year, something like that. Okay, so what is the dependent variable? Dependent variable is I want to predict number of birds. Okay, so number of birds is a count data which you can count. Okay, then if this is the question I can ask you, you can say that since the number of bird is a count data, we have to first find whether mean number of bird and variance number of bird are same or not. If they are same or approximately equal, we can go with the Poisson regression model. Do you understand? Similarly, other regression model, that 10 different regression model I'm going to teach in next couple of weeks. So I'm going to discuss those things. So this is about likelihood function. Likelihood function does what? They estimate the unknown parameter, okay? They estimate the unknown parameter.